All right, so, well, like we talked about at the beginning, finals 25% of your grade, so it's a hefty chunk. You definitely, I mean, I'll try to throw some questions on there that are less programming and more knowledge based. I guess my exams usually have 10 questions on them. Each one's worth 10 points. You should definitely know what Git is and what the purpose of GitHub is and understand those things. Design patterns are fair games. Fair game, what is that? What is a design pattern? What is MVC? These are things that we all need to know. That should be free points on the exam. And the worst thing that's going to happen is if I give an exam that's half programming and half stuff like this, and you bomb the programming and also miss most of these, I'm going to probably have pretty little patience with that, I guess. There's not an excuse to not understand these top level concepts, right? So understand that MVCs, model view controller, it's a good idea to keep our implementation and our logic separated from each other. So just like we've done in Android, where we have our layout in one place and we have the logic behind it in another place. Understand the concept of an activity. What they are as they relate to your Android application. What's a view? Same thing. So things like text views and buttons, these are all views. The concept of the activity lifecycle. So while an activity is running, it goes through various periods of logic. And those things kind of, we have an opportunity to do something when an activity, for example, first is created, when it goes into the background, stuff like that. So these are various points of time where we can interject our will into an app as things are happening. The auto-created R class, we should understand that guy. That's the dude who keeps track of all of the current widgets we've put on stuff. So we use that in conjunction with an activity where we say something like this.findView by ID and then pass it r.id. Whatever the name of our widget is. So the Android ecosystem automatically maintains this class called R that so that we can conveniently access the names of our widgets on our screens. Concept of data representation languages, XML, JSON, kind of what the purpose of those guys are for giving meaning to information. These aren't programming languages. This was our very first quiz. Write a method named count spaces that takes a string as a parameter and returns the number of spaces contained within the string. This would be an example of what I would consider to be an easier programming question on the exam. And that quiz did not go well. So, this is a type of question that you should be able to do in this class. If, the harder end stuff, I get that it can get confusing, but this is stuff from 535 that shouldn't have been all that difficult in 535. Concept of a pointer. So all objects, they hold memory addresses, and pointers point to places in memory. We've had tons of practice with pointers in here, dealing with linked lists and stacks and queues and all that stuff, hooking things up, disconnecting things. So that should be something we should all be able to do. This was a concept we talked about with how string literals work in Java, where we can say a string S is equal to hello, string S2 is equal to hello, and if we compare S to S2, it's going to be true. They're the same. But if we have string S3 as a new string hello, S and S3 are not equal to each other, because they have a different memory address. So this deals with the literal space versus the regular memory space for our where strings are stored in Java. So anytime we have the new keyword present, brand new memory is requested. So this was the lesson where we talked about how strings don't compare themselves to other strings using double equal sign. we use the dot equals method if we want to compare the content of a string. All right, concept of arrays. Again, this is from 535. These guys are fast, live in contiguous memory. This is the syntax for building an array. I should be able to ask you to build an array capable of holding 25 integers and fill it with 25 numbers. That should be something that is very easy for you to write. All right, now the concept of data structures kind of leverage that from arrays. So the idea of arrays is, here's what's good about them, but here's some of their weaknesses. And the main weakness with arrays is that they're memory inefficient in that we need to make them large enough to hold all the data they were ever supposed to hold right at the beginning. Therefore, they're not very flexible. So that's when we started talking about data structures. Specifically, the first things we talked about were linear linked data structures. So these are things like linked lists, stacks, and queues, as opposed to nonlinear like trees. All right, so we talked about linked lists, so we can kind of think about this guy as being like a competitor with an array. So these guys are very memory efficient in that they only take up the exact amount of space that's required to hold the exact amount of data that we are currently holding in the linked list. And it's because they do not live in contiguous memory. What does contiguous memory mean? Memory in a row. Yep. So linked lists do not live next to each other in memory. We have one element here, another element here, and then we have a pointer that points to where that guy lives. All right. So these guys are relatively slow because in order to go through a linked list, we have to traverse it. We got to go to the beginning of the list and then follow the yellow brick road throughout the list to get to places. All right, then we have, so when we started talking about linked lists, we introduced this idea of a node. So this is kind of one of our main building blocks, a Lego that's used in all of our linear linked data structures and realistically all of our data structures, right? We had it with our trees, we would have it with graphs. A node is something that holds our information plus the pointer to the next thing or to the next multiple things. So for instance, a node in a binary tree has up to 2 things it points to. All right, so understand how linked lists work. If I gave you a picture kind of like this, and I said, here's a new element, 5, write the list of steps that it would take to insert the 5 before the 3. So you would have to write the steps out. I mean, you should be able to write the code as well, but this is a matter of taking 5, setting his next node to point to 3. So we need to figure out where 3 is, set 5's next node to point to him. Then we can make the guy right before him, 4, make his next node point to 5. So that goes 4 to 5 to 3 to 7 to insert something. So we need to understand how those connections work because the point is what we don't want to do in this example. We don't want to have 5 pointing there and then say, oh, well, the very first thing we should do is we should make 4 point to the 5. Why is that bad? Now we lost the 3. Nothing's currently pointing to this 3, so we've lost it. We no longer have a way of getting to that guy. All right, so the order of steps is very important. All right, here was our next quiz. Write a function that would live inside of a linked list class that returns the number of nodes that currently exist in the list as an integer. So I tell you, you should traverse the list and count each node to get this number. I said you can assume that the node class has public methods for get payload and get next node, so you know whether there's something in there. And you can assume that the linked list class has access to the front of the list through a variable of type node called head. So the idea is you were to traverse the list and keep adding one until you finally got to a node that didn't have a next node. Okay? Something like that is a type of programming question you should be able to do on the exam. I mean, the hope is once you saw the solution for some of these things after you took the quiz, you realized that there wasn't all that much to it. So these are things that we need to be able to do on the final. So here was that example. So if we're pointing to nothing, return 0. Otherwise, start off at the beginning of the list, start count off at 1. As long as we have a next node, set cur node equal to his own next node, increment count. Ultimately return count. So this is that code that counts the number of elements in a linked list. This is something you should be able to write. All right, when we practiced linked lists, we wrote an implementation of something called huge integer, which was a way of representing arbitrary size integers. Now, for our example of this, we only worked with positive numbers, right? We didn't worry about negative numbers. And so a huge integer was a linked list where one number linked to another number, linked to another number, and the far right one was the ones place, the next one was the tens place, then the 100s place, and the 1000s place, so on and so forth. All right, and then we needed to be able to do what, just addition, or was it addition and subtraction? I think it was just addition, and that's something that we learned in 3rd grade. How do you add two numbers together, right? With carry bits and stuff like that. Okay, so yeah, I mean, it would be hard to come up with a question that would specifically drill something from this because that's a little bit maybe too much code for an individual question. But I mean, some of the mechanics you did in here are certainly fair games, certainly things you should know. At the very least, you should understand how the shunting yard algorithm works. You know, if I gave you a string that had elements in it, and I told you to show me the output queue at the end of processing the input queue, something like that. You should see how the things move. All right, what are the 3 required functions of the stack data structure? What does each one do? So I kind of remember, I think we did okay on this quiz. This was kind of a layup quiz, so we should know what the functions are of a stack, push, pop, peek. If I gave you a stack data structure, gave you, an implementation of stack, and I said, write the necessary code to reverse the elements in this stack or something like that, you should be able to use a stack to do that. If I have a stack of 3 things, for example, I have a 1, a 2, and a 3. That's in my stack. And I want to reverse that so I ultimately get a 3, a 2, and a 1. How do I do that? How do I go from this stack and get this stack? All right, this is going to be my attempt stack. Okay, so this is a second stack. And what do I do to this stack to get this stack? All right, so I'll pop from here, which will remove the 1, push it here. Pop from here, which will remove the 2. Push here. Pop from here, which will remove the 3. Push here. And then how do I make this stack point to this one? Set its variable name equal to this guy. So if this guy was originally called my stack, and this guy was originally called maybe temp, in the end here I would say my stack is equal to temp after all my pops and pushes. So that ultimately my stack pointed to this stack upside down, the reverse of its original self. Make sense? So we should know how stacks work. All right, this was our shunting yard stuff. So go back and rewatch the videos from this and make sure you understand how shunting yard actually functions. Here's when we were talking about the string tokenizer. We covered it in class. We covered it again today. I'll probably put some question on the exam dealing with the string tokenizer. Should be a fairly easy thing to use. I mean, just a matter of loops and take something that's delimited, flip it apart, and so maybe I would say something along these lines. Here's a sample question. Given a string, that looks like this. Write a function that sums all of the numbers in that string. All right, so then the idea here is you should use the string tokenizer. That's one tool you're going to need. What's another tool you'll need for that? ParseInt. You're going to need integer.parseInt to turn each of those strings back into an int. All right, so why don't we do this actually? Why don't we take, how about we take like 5 minutes, try to write this function. Do it on your own. I'm not going to collect it or anything. So I'll pause this. All right, so we have a string like this. We need to split it all up, use integer.parseInt. So I'll just throw the function in, throw it inside node here real quick. We'll delete it afterwards. So we'll say public int sum string. This guy will take a string s as a parameter. We're going to have an integer that's going to hold our sum. We're going to have our string tokenizer. And we're going to be tokenizing s on the comma. And then we're going to go ahead and have a while loop that's going to go through all the tokens. So while st.has more tokens. We're going to say sum is equal to sum plus integer.parseInt st.next token. Return sum. Something along those lines. We're summing up a bunch of numbers, start off at 0. String tokenizer is the tool we're going to use to split this guy up on this delimiter. Go through all the tokens in ST, so since every single time we ask for ST's next token, it removes that token from it. That means it's gone. So as long as there's still tokens in ST, remove it, convert it to an integer, add it to my sum. Once we're finally out of tokens to do that to, return the final sum. something like that. If you wanted to support possibly having spaces in with the commas, you could have always done a dot trim on that. That would guarantee you didn't have like an extra space. If you did 1 comma space 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 2, something like that, putting the dot trim on there would solve that problem. But that's just, details. If you did everything else except that, that would be perfectly acceptable, and I would be thrilled if that was the situation. All right, so how did we do on that one? If you were grading yourself on your solution on what you came up there, what would you give yourself? How many would give yourself an A? B. A C. An R. How many would give yourself an F? All right, so we all feel like we passed it. Some varying levels. All right, so where did we struggle on that one? What was the difficult part of this question?
So I initialized some, but didn't know that I had to add every converted string into some.
Okay. So what did you think you needed to do? Or what did you try to do?
I imagined the string was already given to me. So instead of string tags, I had the strings in. I had taken in 1, 2, 3, 4, 5 in place of string tags. So I tried to manually add it, which beats the purpose of it.
Oh, so you didn't even use a tokenizer?
No, I used a tokenizer.
So what did you try to tokenize?
So where it says the sum string, so public in sum string, instead of string S, I took in the string 1, 2, 3, 4, 5.
So you took in something like 1 comma 2 comma 3 comma 4 comma 5, like that. Okay, well, I mean, that's fine. So, I mean, that's illegal code, but you could presume that S is that. So, for your example, you can say, well, as an example, S could be equal to that string, but you should still write it generically. We're splitting S up on that. I mean, otherwise you could have split that up. Okay, well, fine. So if the rest of your logic was fine, I mean, understand that this is a generic, the whole purpose of a function is for it to be a reusable chunk of code that we write once and call multiple times. So if we have a string hard-coded in here like this, as opposed to using the string that was generically passed in, kind of defeating the purpose of the function. But even outside of that, let's assume that you did this. So you tokenized this guy on this comma. Okay, what about the rest? What was problematic from that point forward? Because this is going to produce for me what? ST is going to hold the tokens 1, 2, 3, 4, and 5. So I have all those tokens now. Now what? What did you do next?
That's where I was almost trying to just manually add 1, 2, 3, 4, 5. But that kind of beats the purpose of having a function.
Okay. What was challenging for other people?
Not just comma, maybe other special characters. How do you write the code for that?
Like instead of a comma? Well, what other special characters?
I mean, like braces, something else, anything.
Well, I mean, you have to know what the format of your string is. So if you're going to have comma delimited numbers, then you assume it's commas. If you want it to work on, instead of commas, if you want to assume it's colons like this instead of commas, well, then you just split it on the colon. Does that make sense? Now, the tokenizer would let you split a multiple delimiters, so you actually could do that and then tokenize on both the colon and the comma. So that would treat the colon or the comma as legal delimiters of this. I wouldn't make it that difficult since you only had to deal with commas, but that would technically work. So when you were solving it, did you actually think about how to solve a harder problem?
I was just thinking, I thought you gave me an example. You just gave us a format, and if there's a number and special characters and a number, how do you solve that? What I was thinking. So
Okay. Okay.
First,
Did you use the string tokenizer?
yeah, but we can't use it in this case, right? So that's what I was thinking.
Sure we can. I just showed you.
Oh, but all the special characters.
Oh, you mean like every special character? So anything that's not a number is a legal delimiter, effectively, is in your world. Okay. Okay. You actually could do it.
Just take out the delimiters and make everything as tokens and just take the numbers out of the tokens. If it's an integer, take the token. If not, just leave it.
Yeah, the problem is that you don't know what all the integers are. You have the individual digits as tokens, but if you had 11 there and one of your tokens was a 1, you would get nothing on either side of this because these are the actual delimiters themselves. There is a version of the tokenizer that also takes in whether or not you want to return the delimiters. That would then give you a 1, a 1, and then all the rest of this. It would give you 3 tokens in this case since you're tokenizing on a 1. So I'm not sure they would be the best tool for this guy. But in this case, we were just supposed to do it on commas. So something like that. But even if you wanted to write it your way, then you just wouldn't use the tokenizer. You would write your own thing that only looked for digits, only looked for values that were 0 through 9, and collected them.
I was thinking if it is 99, then if there is no delimiter in there, then it gives us tokens as 1, 2, comma is a token 2, right? If there is no delimiter.
Well, I mean, comma is a delimiter, not a token.
I mean, in case if there is no delimiter, if you put it as blank or something.
Okay.
Then the comma is taken as token 2, right?
So if you had something that looked like this string, and you put in the empty string as your, it's going to give you this entire thing back as a single token. Just one token, and it's the whole string. Yeah, so the tokenizer lets us solve problems, and these are common business problems, right? Where you have data that's formatted in a certain way. And this allows you to split it up. Okay. Another stack example was our Towers of Hanoi problem, where we did push pop in the context of having a tower. Then we, I guess, move stuff around from there. So we part of the skill we learned there was working with, part of the skill we've learned with several of the assignments is working with view groups like we did today, where we're adding text views, we're removing text views, putting things between multiple view groups. And something we learned is that you cannot have a view living inside of two view groups at the same time. Right? If you think back to Towers of Hanoi, when we couldn't just take the top text view out of our left tower and add it to our temporary storage location or whatever until we had first removed it from the left tower. Otherwise, if we tried to put it in the temporary storage thing and it was still in the left tower, it would die. It would crash. Because we cannot have a view living in two different view groups at the same time. Because then we've lost our layout. Understand what an intent is. So going from one screen to another screen is how we've worked with intents. The difference between a singleton and using our extras for getting information between two screens. This is where we were looking at the activity lifecycle. So on create, on start, as compared to in iOS, the view controller lifecycle. So kind of the idea with mobile applications that we have this concept of a life cycle that allows us to go through and respond to things during various times that the application is running. So when it's first born, onCreate gets called. Every single time the application starts, an activity starts, this guy gets called. So when we came back from the previous screen, this guy would get called again. Singletons, what's the purpose of those guys? Understand those guys. All right, so these were our linear linked data structures. So stacks and queues are all special implementations of linked lists. Stacks are last in, first out. Queues are first in, first out. Okay, so again, this is like a review of the arrays versus linked list stuff. So arrays are linear, but they're in contiguous memory, so they're not linked. They're fast. Linked lists are slow. Arrays are memory inefficient. Arrays are memory efficient. I do like conversion problems. So I'll probably try to put a question on there that has you take something like this and converts it into another level. So for instance, what if I asked you how many bits in 237 megabytes? How many bits in 237 megabytes? Take a minute and solve that. All right, we got an answer? How many bits are in 237 megabytes? What's this? Read the numbers again. 2. Okay. 53651. 52. 512. Like that. All right. So let's see if that is right. So you think 248,536,512 bits in 237 megabytes. All right. So 237 megabytes. 237 megabytes is how many kilobytes? So that's 237 times 1024. That will get me kilobytes. Times 1024 will get me bytes. Times 8 will get me bits. So 1,988,100,096. Who got that answer? You got that one right? Well, you got it wrong. Did you get it right?
I did correct, but the calculation is wrong. The process is correct. I didn't use my phone.
All right. You should definitely be able to do that on the exam. I mean, this isn't even a programming question. This is an IT stuff, and you should be able to convert values like that. You've done that before, right? Converting sizes like that before. This really should be trivial knowledge. Let's see. We talked about some of this high definition stuff when we were trying to talk about the amount of information that goes across, talking about different internet connections and things like that. So I will try to ask more questions about that since the programming is going to be rough. But like I said, if we did this on an exam and I gave you this question, I would have viewed that as an automatic easy 10 points. And one person got it right. So that's problematic. So if I'm going to give you something other than some programming questions, you need to get those right. So practice those things. Talked about binary trees last time. So I should be able to ask you questions about in order, pre-order, post-order. Maybe I give you a tree and I ask you to tell me what the order would be for in order, pre-order, post-order, how you would visit them. Should be able to do that. All right, like I said, 10 questions, each one worth 10 points, so 100 points. I'll probably give you 2 hours to work on the exam. So after you're done, you can take off. I thought that at some point they had said from the other class that somebody was going to do food or something, but I haven't heard anything from that, whether they were bringing food in and we were all going to eat or whatever. But so as far as I know, that's not happening, even though that was discussed at some point. So if you hear different, let me know.
As far as the, I mean, I know we should understand the theory behind every single thing that we've done so far, but as far as the color, they have to do this on concentration.
Well, you mean like which things to definitely look at versus which things not to focus on so much? Well, I guess I would probably ask questions more like those quiz questions. So similar to our first quiz. Like that one. Count spaces, how many spaces are in a string? I'll probably ask several questions that are along those lines. Write a function that does this, write a function that does this, write a function that does this. So figure about, 4 questions or so are probably going to be like that. Maybe 5. And then the rest of them will be, what's MVC or a conversion question, things like that. Make sense? All right. So questions about any of that stuff or what might end up being on the exam or the format of the exam? Anything you want me to review specifically? Going once, going twice. All right. So I guess let's call it quits because the other class already let out. I know that some of them are your ride. So so next week, beginning of class, will be the exam. So you'll have 2 hours to take it. So we should be done by 7 p.m. next class. All right. I'll see everybody next week.